This came in 2010. This came in 2010. Let's see the problem. A non-conducting sphere, that is insulator, a non-conducting sphere of radius capital R has a positive charge capital Q uniformly distributed over its entire volume. A smaller concentric spherical volume of radius R less than capital R is scooped out of the sphere. The magnitude of the electric field E at a point inside the body at a distance x from the center r less than x less than r is k is 1 upon 4 pi epsilon naught constant. Option A kq by x squared, option B kq by x squared into r cube upon r cube, option C kq upon x squared x cube minus r cubed upon r cubed, option D C. Okay, look, first of all, let us understand the meaning of the word non-conducting. See, because it is non-conducting, we can say that the charge stays inside. Had we said that it is conducting, it would have followed immediately that all the charge will sit on the surface. Okay? Well, now they are saying it is uniformly distributed over its entire volume. So Q is the net charge or total charge. So can we talk about volume charge density? Yes. Q by 4 by 3 pi r cubed. That's the volume charge density. Okay. Okay. Now it is being said that some concentric spherical volume is being scooped out. That means it would create kind of a cavity there. Okay, it would create some kind of cavity, but it will also take some charge with it. Okay, it will take some charge with it, but that will not cause any redistribution at all because we have got insulator there, right? So I can say net charge, okay, net charge after the scooping. Okay, net charge after the scooping, what would it be? Inside, okay, let's put it this way, net charge after scooping inside a sphere of radius x. Okay, inside a sphere of radius x, what would it be? Look, it is a charge density into volume. Will it not be charge density into volume? Yes. So that is Q by 4 by 3 pi r cube. And what's the volume now? Volume would be 4 by 3 pi x cubed minus r cubed. Have you understood this? Yes? Okay, that's the volume. Okay. And can we apply Gauss law? Yes. By Gauss law. And radial symmetry. E into dA, okay, of surface area of a sphere of radius x is equal to rho v upon epsilon naught. Correct? Rho v upon epsilon naught. So what can be said about E? 1 upon 4 pi x squared. 1 upon 4 pi x squared rho v upon epsilon naught. Okay, 1 upon 4 pi x squared rho v upon epsilon naught, and I think we have got the answer because none of the options except option C contains x cube minus r cube. Therefore, correct option is C. But let's tally that. Okay, let's not be just blind and go with say. In the exam, you may do that, but because we now have enough time, we can. Yeah, even if we know it is true, we will still do it. Okay, great. Okay, yeah, I need to recall those हाँ ठीक. Okay, so 1 upon 4 pi epsilon naught, I'm writing it separately. 1 upon x squared is there, rho is there and v is there. Rho v. Okay, in rho v, can we cancel a few things? 4 pi by 3, 4 pi by 3 will get cancelled. So it would be q upon capital R cube into x cube minus r cube. 1 upon 4 pi epsilon naught is k, q is there, squared is there. Okay, k is gone, q is there, x squared is there, so r cube there, so x cube minus r cube. Okay, so option C is correct.